Hi, today we are going to build feature engineering pipeline. Now your model ready for the deployment. During the development process, you already know how to clean and which features to create. And also you select a feature based on the feature importance. First, we need to create the feature table because we need to map our source to target. Our source is the fact tables and dimension tables, and then extract the data from there and transformed, clean, and creating features, and then we store in the feature table. So if you click the create table SQL, you can see tables from previous project. I'm going to create this table named feature delays, and we have these features identified during the model development process. So save it, and then I'm going to create tables, copy Docker container ID of app Postgres. Now you can see feature delays table created. And next, I'm going to create new deck for the feature engineering pipeline. You can create two decks. First, you need to load the data one time. Another deck is hourly running based on the earlier deck. Keep in mind there is a two use case. So this time I'm gonna assume that we already have existing ETL pipeline which extract data from API to and then store data into the master tables, which is fact and dimension tables. To transform data one time, I'm going to create this stack first. We can import libraries and define argument, create tag. Within the tag, we define three tasks, define the task dependencies. And then we can create one folder inside script feature engineering features. Now another one is load features.py. We can go to transform features. If we go to the load features.py, those two modules are using SQL execute query operator. Our task ID and connection ID is the same as previous project. You use the SQL query select those variables from multiple source. From fact measurement, you can join all those dimensions using your foreign key. Then if we go to transform features, I will explain the transform feature. You got the data from previous task, which means you fetch the data from master tables, fact and dimension tables, and from earlier task, and then you got the data. Create the data frame based on these columns. Transform the base time to be used for concatenation with the base date to create the timestamp. This logic you're creating the timestamp, so it's a datetime object, and then after that your timestamp to be set as a datetime index. After created the time series data based on the city, you're doing the cleaning and feature engineering and then append to the transformed features. So we can go cleaning data stage. During the cleaning data stage, what we do is we need to do the pivot based on the category, copy the original data frame based on the city. We create data pivot, and another one is data common. You're only going to select first element after you group by the timestamp. On the other hand, you have a pivot. You're going to use pivot function based on timestamp index, timestamp as an index, column name is category code, and then value is measurement values. So you got the data pivot. You're gonna generate a target variable based on this function, because during my model development process we don't have a delivery delay variable, so I created synthetic data by using this function. What this function does is every row you're going to add hours of delay, summing your delay hours. So this is the logic to creating target variable. Let's go back to cleaning data stage, and then so we got the target variable calls delivery hour, and then from pivot tables, and we can merge pivot data and common variables together. You need to do the resampling based on 1 hour. It is already hourly data because we collect the data hourly, but the reason why I do this step is to identify the missing values. So if we resample the data based on 1 hour, and then you will get all the timestamp that is hourly aligned, and then you will notice that there's missing values in the data frame. Separate numeric features and category features. Interpolate, I will use interpolate based on the time, and also for the categorical features I'm going to backfill. And another one is change types of variable, because this variable pty is types of rainfalls. Fill this missing value based on mode, most frequent value, the missing value imputation done. And then after that I drop unnecessary columns. Data cleaning stage is done. Next stage is we need to do the feature engineering. During the feature engineering stage, we're going to create the sine hour, cosine hour is a time variable. Create the weekend is weekend variable. Need to change day of week variables to the categorical. Convert is holiday true or false to integers. Then we create a log variable. We fill the no value with backfill. All this transformation done. Then we append to the transformed feature list per each city. So after we transformed all the features, then we need to load features to feature table. To do that, we already defined the callback function here. If we go to load feature, then there's one callback function called load features. So you got the transformed feature from previous task, and then you validate whether you received the data from previous task. We reset the index. Our target column we define here. These columns are identical in the table schema. We validate whether any columns in the previous task are missing. Then we initialize Postgres hook. We get the weather connection. We defined previous task. We got the connection and we got the cursor. We make tuples and we get the list using list comprehension. Why we do this is because we need to insert values into the tables based on each row. So we define insert query, insert into the target table, feature delays, and values are here. The record, you have an insert query here, and then using this cursor. Then also I define that this on conflict and do nothing to avoid the insert conflict. And then this is the composite primary key. So your timestamp and city makes unique. Then we insert the data using this and commit. Yeah, so this is the logic. You can see the tag name, one-time feature engineering, the one-time feature engineering pipeline. And then if we go to the DB interface tool, feature delay, we loaded this 4 data point, loaded correctly. The log variables now we cannot find, because at least we need 2 previous data point to calculate log variable. We need to handle this one for the future. Then once we loaded one-time feature engineering pipeline, we need to modify this one to align with two previous pipeline for executing every hour. You can create new file here. Default argument tag. Make sure your schedule interval is every hourly run. Create task dependencies. And if we go to transform feature, I created this transform feature hourly function here, these modules here. I will explain this tag functionality is almost the same as the previous one we defined, but the difference is we scheduled every hourly, and then first we are waiting for the previous tag, which is the loading data to master tables, fetching the master tables data. The difference is this one, almost the same, but first we creating the base date and base time to the timestamp, our current stamp in UTC, and get the intervals 9 hour. This means we are converting to UTC to KST. We can get the timestamp that is 2 hours earlier. This one is getting data in current timestamp in Korean time. So we are selecting between 2 hours before and current timestamp. So then we can calculate log variables. That's why we need 2 hours earlier timestamp. We got newest data, and then we transform. We send the data to the next task. Transform features. We can see the callback function is transform feature hourly. This is almost the same functionality, but only difference is this one, because after we transformed the three rows, once we created log variable, we don't need the previous timestamp, so we only select the newest current time, and then we append, send it to the next task. The last logic is the same. Now you can see hourly feature engineering. So make sure tag schedule aligned correctly to show. So now we are streamlined the three tags from API and then master tables to the features. If you like the video, please subscribe, like, wait for the next video.